Good morning. I think I got everything set up. I apologize for late start. Are you guys able to... Are you guys able to see anything? Because on my screen it's not showing things as being broadcasted. You can. Okay. Oh, as long as you guys can see everything, that's fine. And if you're responding, that means you can hear me, so that's good. Alright, then we'll just, we'll work with that. Yeah, my weekend was good, Gavin. How about you? So we're going to start from these notes. I'm also curious, did you guys get these notes delivered to you either today or Friday? Because I got an email saying that some of them went out on Friday. So I'm curious if you guys received this packet by now. Because if so, that'd be great. You did. Okay. Ben did not. Okay. My guess is by today, the last ones should go out. All right, Abby got... So, seems pretty mixed. All right, so it looks like majority of you did get it. Some of you did not. If you didn't get it, my guess is by today, when the buses go out to deliver like lunches, or they're mailing them out. I'm not sure. But that is definitely good news that people are receiving these, so that we don't have to worry about printer issues and stuff like that. And this unit is long, so this is gonna last a long time. So if you didn't get them, hopefully by the end of today you get them. I'll ask the same thing tomorrow. Another few things I want to announce is grades are being submitted for kind of like a progress report, because as you guys know, there's no report card for the third marking period. Everything's being combined. We've only had 2 assignments done remotely. Everything else has been done while we're in school. So a lot of your grade up to this point is from when we were in school. And I've only graded a few of the weeklies right now, but like I said, I am being generous with the grading. A lot of 20 out of 20s, some, 18 out of 20s if there was a lot of mistakes, stuff like that. So keep that in mind. As far as if you did the test assignment, you'll notice that I'm putting a test grade in the grade book. It is likely higher than what you actually got on Google Classroom. What I'm doing is I'm considering what you got on the first 2 tests, and I'm basically making sure, I'm taking the average of those 2, and I'm basically boosting it up by like 20 points or something like that. So let's just pretend you had a 70 test average for whatever reason. That means for the quadrilateral test, I'm putting in a 90 in for it. So it boosts your test average by 10 points. If your test average goes up by 10 points, that means your overall average goes up by 5 points. So like I said, it was going to be a generous extra credit, or mandatory extra credit. So if you did that, it is greatly benefiting the people who did that. For the people who had 100 average, you guys, some of you have like 106 now, so it's going to be hard to get below that now. So it's really good. I graded some of them. Not all of them have been graded. So if you go into Google Classroom right now, it is unlikely going to be graded. I'm doing the ones in my email first because some people email them to me. So I'm getting those out of the way. Then I'll do the Google Classroom. But you guys can check out kind of that stuff. If you have any questions on how I'm grading it, I think I'm being very fair and generous with the grading. There's no new weekly this week. I'll probably put up another assignment later in the week for us to do. Either a homework page from this packet, maybe the quiz assignment from this packet, whatever I think is fair. And I'll probably grade that as like a homework. Because the weeklies are quizzes, you guys did a test. Maybe let's get a homework grade in there. So if you have any questions on any of that, let me know, because our grades are due on Wednesday. If you've been attending this and handing everything in, I can tell you right now that your grade is definitely benefiting from that. So that is definitely good. What's the other thing? There's definitely something else I wanted to say. Oh, Thursday. If your screen is blurry, just refresh the page. Sometimes it's a buffering issue. Just try refreshing the page. Thursday there's a faculty meeting, and it's right before the class would go live. And it's likely going to be longer than an hour because these meetings have been pretty long. So what I'm going to do is we're not going to stream on Thursday this week, but that's fine. We'll probably have an assignment by then. You guys can spend the time working on that. You can ask me questions and stuff like that. So I won't stream on Thursday, okay? But we will do the other 4 days, Monday, Tuesday, Wednesday, and Friday. So you guys can have a little break in the middle of the week. So we're going to jump right into the next section of our notes, which are congruent chords and arcs. I'm not going to spend too much time on this page. I don't think it's going to be too necessary. It's also pretty easy. We're really going to start jumping into kind of one rule with circles to the next. And I said in the beginning of the unit, there's a lot of rules with circles. So we'll try, we're going to try our best to kind of keep them all in check, memorize them all, and so forth. Well, luckily for you, you probably don't need to memorize it because you can look them up. So that's good. So the first one is going to be congruent chords and arcs. So two chords are congruent if and only if their corresponding arcs are congruent. So you'll see this double arrow right here. We've never really gone over what this really means. It stands for the words if and only if. Basically what it means is that the converse is true. You could read it backwards or forwards, and it's going to be true regardless. Because we've seen statements where you could flip them and they're not true, and then some of them you can flip them and they are true. This is just one of those cases. So one of them is going to be that AB is equal to CD, and these are line segments, CD and AB. So that are these two right here. If these two arcs are congruent to each other, so if these two chords are congruent, then their arcs are going to be congruent, AB and CD. So that's kind of what this theorem is saying. So that means arc AB is equal to arc CD. And when you think about that, that should make sense. If we know that the yellow ones are congruent in length, that means AB and CD, they're going to have the same angle measure, they're going to have the same arc length, and so forth. The second one is going to be, they are equidistant, and we've used this word before. Equidistant just means of equal distance from the center. Should we have it? We could. We could have the congruency symbol or equal. I guess I'm using them interchangeably here. It doesn't really matter. But I guess if I'm being super technical, because I did not put the M in front of it for measure, I suppose we could use congruency, but it really doesn't matter. So if they're equidistant from the center, what that is going to mean which says that same condition if line segment AB is congruent to CD, which are those big chords. So if AB is congruent to CD, if they're equidistant from the center, that means the line segments connecting them. The shortest distance from a line segment to a line is going to be perpendicular. So that means that these two lines right here that I have highlighted should also be congruent to each other. And you'll notice they're not a radius because they don't extend out to the edge of the circle. But if they're perpendicular to each other, and we know that those chords are congruent, those two lines must be congruent to each other as well. So FE is congruent to EG. So those two rules kind of go together. So we get all that just for having two chords in a circle congruent to each other. A lot of times they may not, draw these lines in, but we'll know that they are true. So we'll see some stuff like that. Another rule is if a diameter or radius is perpendicular to a chord, then it bisects the chord. And it will also bisect the arcs as well. So that means if a diameter or radius is perpendicular to any chord in a circle, it is essentially the perpendicular bisector. So what that means is if EH is perpendicular to AB, so let's take a look at the diagram where that is. If EH, that's the radius, is perpendicular to AB, that's the chord, then we have two things which are true. The bisecting piece, it bisects the chord, so AF is congruent to FB. So that's these two right here, BF and FA, as well as the arc. So we could actually say here and here are congruent to each other. So those pieces will also be cut in half. So the measure of arc AH is congruent to arc HB. So it's a lot to take in, but it's not terribly difficult. It's really not that bad. When we get to some examples, they're going to show us some arcs are congruent. We're going to find the chords. They're going to give us some chords are congruent. We're going to find the arcs. It's overall not too bad, and this doesn't come up quite that often. But we'll take a look at it. We'll practice some examples, and we can kind of see what they look like. So number one, did everyone get that? I'll leave it up for another second. All right, let's take a look at number one. So number one, they tell us to find the value of x, and the only information they're telling me is that SR and ST are congruent to each other. So that tells me if the two chords are congruent, that means their corresponding or their intercepted arcs are congruent. So that's an intercepted arc, that's an intercepted arc. That means these must add up to, or sorry, not add up, they are equal to each other. So 115 equals 7x plus 24. So pretty simple, easy algebra for us to do. it 91? I think. Yeah, I think it's 91. Then we're going to divide by 7. So x is going to be equal to, let's see, 7 goes 9 once. 21. 13? And nothing telling us to plug back in, which makes sense. We wouldn't need to plug back in. We know that this should be 115 degrees anyway, but it's a good way to check. If you plug in 13 into this expression, we should get exactly 115. Number 2 is going to be basically the same, along the same exact lines. They gave you the two arcs are congruent. You set them equal to each other, and that's it. So I'm going to skip number 2 because I think it's a little simple for us. We will go to number 3 because the only difference with number 3 is they are going to require us to plug in, which is pretty typical for us to do. Find the value of x first, then plug in. The only information that they're giving us in this one is that the two arcs are congruent to each other. So if the two arcs are congruent to each other, they gave us the chords. So that means they are congruent to each other as well because those arcs are congruent. So we would set the two expressions equal to each other. So 9x minus 34 is equal to 4x plus 1. And then we'll solve this for x. But we won't be done there. We will need to plug in to figure out what xy is. So let's see. We're going to add 34 to both sides, subtract 4x. So we get 5x. I'm going to add 34 to both sides, which is equal to 35. We're going to divide by 7. Oops, sorry. We're going to divide by 5, and we're going to get 7. But not our final answer. We do need to plug in, and since we know they're congruent to each other, it technically doesn't matter which one we plug into, but because I say xy, I will plug into the 4x plus 1. Also, plugging the 4x plus 1 is probably a lot easier than plugging into 9x minus 34. So xy is equal to, let's see, 4 times 7 plus 1, which is 28 plus 1. So I think we get 29. Number 4 is exactly the same, but just the opposite, kind of like what we saw in number 2. Set them equal to each other, plug back in, and then find the value of arc RS. Except in this one, they give you that the chords are congruent. So if the chords are congruent, that means their arcs are congruent. So I don't think we need to do that because it's kind of exactly the same. Then we can get into ones like number 5, and these are ones that I think are more of appropriate level because they are slightly more challenging, because they require you to kind of think about the diagram a little bit more deeply. It's not just blindly setting things equal to each other and stuff like that. So in this one, all we got to do is find the value of x, so that's good. They give you two congruent chords. That's good. So that tells me that these two arcs are congruent, but they didn't give you anything about xy. But instead, the information that they gave you was this 76 degrees. So we got to figure out, how do we use this 76 degrees? Well, there's a few things we could do here. First and foremost, what I kind of see first is, well, the two arcs are congruent, so we can mark them like this. If the arcs are congruent, and we usually don't do this as often, but it is fair to call xy also 6x minus 20. We could absolutely do that. And then we know every arc in the circle, so we could add all of them up and set it equal to 360 degrees. So 6x minus 20 plus 6x minus 20 plus 76 equals 360 degrees. So we get 12x. So I'm going to combine like terms. Then my non-x's, I get 76 minus 20 minus 20, so that's plus 36. Subtract 36 from both sides. So we get 12x equals 294. Therefore, x is equal to, and that is a final answer. We don't need to plug anything in. It's going to be, what is that, 2? Does this work out evenly? Abby, I was going to get right into that just after. But yes, that would work. Oh, yeah, you do. That's for some reason I'm reading that as 64, because that is what you should get. Which makes sense, because I'm unable to divide that in my head. That should work. So this we should be able to divide. We still get 27? Apologize, I do not have a calculator handy because of my computer issues. But I think it's 27. If I'm wrong, just let me know. Actually, I know you guys will. I see 3 people said 324, so I know you guys will keep me in check. But that is our final answer. Now I want to go back to what Abby just said, if anyone read that in chat. It says, can't you subtract 76 from 360, divide by 2, and then set 6x minus 20 equal to 162? And yes, absolutely. That is why I mentioned at the beginning of the problem. I'm going to go with what I see first. And what I saw first was the method that I did. But if you know that this is 76 and those two arcs are congruent, you could subtract 76 from 360. Let's see if we can do this mental math correct. That's going to be 284. I'm going with 284. And then we could divide the 284 by 2, because that's basically the 284 is the entire yellow arc. But we know that the arcs are congruent, so we can just divide it by 2, and I think we get 162 for each arc. So if you know the arc is 162 and 6x minus 20, you could set those equal to each other, and you should get exactly the same answer, 27. Either way is fine. So there's going to be multiple outlets in order to solve these problems, but anyway is fine. As long as you're following the rules of your geometric rules, you'll be fine. All right, so now we get into diagrams that look a little bit more confusing, but they're really not that hard. They give you that MP, which is this tiny little segment in here, not quite a radius. We see that it's perpendicular. That gives us some good information. So if it's perpendicular, that would tell me that these line segments in here are congruent. We don't really need to use that rule, though. We're just going to label it as 5x minus 34. And then Pn is 2x minus 4. Find the value of MP. So because the arcs are congruent, if the arcs are congruent, that means the chords are congruent. So this and this are congruent. And because each part coming from the center is perpendicular to the chords, that is the shortest possible distance. And that goes to this rule right up here, that if you read the top first, 2 chords are congruent if and only if, and then part B says they are equidistant from the center. That's basically the rule we are using. If they're equidistant from the center, these 2 line segments are congruent. So it's a lot of little justifications to kind of get to the end. It's kind of annoying if you saw it in a formal proof, because you have to say all these things. You'd have to say that the arcs are congruent, you'd have to say the chords are congruent, and then you could say that these 2 things are congruent. When it comes to the actual algebra behind it, it's really not too bad. We're just going to set them equal to each other. 5x minus 34 equals 2x minus 4. So I'm going to subtract 2x from both sides. We get 3x. Add 34 to both sides. And we get x is equal to 10. Not the final answer. Rereading the problem, it says find the value of MP, so we do need to plug that back in. So plugging that 10 in, 5 times 10. 5 times 10 minus 34. So MP, that's 50 minus 34, so that's 16? Yeah, 16. All right. So I think that page is good. We can flip over and maybe see some more challenging ones. But overall, not too bad. Number 7 and 8 are along the same lines. Actually, no, we'll take a look at 8. I like 8. So in number 8, the only piece of information they gave us is that these two line segments in the middle of the circle, they're not chords, they're not radii, they're not diameters, they're just telling you that these two little line segments are congruent. But the fact that they come from the center of the circle and they are perpendicular to the chord, that means that the distance from the center to that chord is the same. That is a conclusion that says that these two chords are congruent to each other. So basically, there's just a lot of symmetry when it comes to the circle, especially when there's two things that are congruent. So if those two are line segments or those chords are congruent, a further conclusion we can make is these arcs are congruent. And if those arcs are congruent, we can just set them equal to each other. But we don't want to forget what the problem is asking. The problem does say, find the measure of arc MP, which is this one out here. And that's fine. Even though there's no direct expression for it, you can't plug anything in for x. Everything I have highlighted is about the full circle. So if we find the value of x, we can find each of the yellow chords and then easily subtract from 360 to find MP. So let's do that right now. Let's set them equal to each other. So 9x minus, what's it, 43 is equal to 5x plus 33. Subtract 5x, add 43. So we get 4x is equal to, looks like 76. And I think that's going to be 19. I'm going with 19. Now, if x is 19, we do need to finish the problem and go to and figure out arc MP. But there's nothing to plug in. So what you need to do is you only need to plug in for one of them. Because remember, these two arcs are congruent. So if you plug in for one, you know the other. But this is a great opportunity and chance to see, is 19 really the correct answer by just plugging in for both. But I'll just plug in for the easier one, which is 5 times 19 plus 33. I believe 5 times 19 is 95. Right? Yeah, 95. And then 33 plus that is going to be 128. So each arc is 128 degrees. That means this one up here is also 128. So collectively, the sum of those two, that's going to be 256. That's all of the yellow arcs, meaning what is left over for the value of MP. We just need to take that 256 and then subtract it from 360 degrees. So 360 minus that 256, that's going to be, I think that's going to be 104. Yeah. So arc MP is equal to 104 degrees. So overall, I don't think it's too bad. I think what makes it difficult in the end is, like I said, we're going to be going over so many different rules with circles. It's just going to be, you know, when you're done with the unit and you kind of come back, are you going to remember this specific rule? And I think that's how you're going to feel about most of the rules that we do in this unit. That there's just so many of them, and, you know, which one do you use when? Which one are you going to apply when? And are you going to be able to memorize all of them? Because like I said, there is quite a bit. This is really only the second one we've done. We've done central angles, and now we've done congruent chords. Let's see if maybe we can do one more, something that's just slightly different. Let's take a look at maybe 13 and 14. So it says use the circle below for questions 13 and 14. It says find VW. It doesn't say if it's arc or line segment. Because they didn't use the arc symbol, I'm assuming that they're talking about the line segment, which is a safe assumption. If they don't put the arc symbol, you can assume it's the line segment. They really should put the line segment symbol above it, because in the number 14, they do use the arc. But it says find VW. So I like this one because it's a little bit different in terms of applying the rules. But because of this little piece right here, this 5, and you see that right angle, that means XZ is perpendicular to a chord. So this segment is perpendicular to this segment. And another one of the conclusions that we haven't used so far is that is a perpendicular bisector. So that means these two are congruent to each other. And if they're congruent to each other, you can easily find, using this right triangle, the value of the radius, or not the radius, but ZW. And if you know ZW, you can easily figure out the entire line segment by just doubling it. So in this problem, it's just hidden that this is just a Pythagorean theorem problem, and then you just got to double at the end. So with Pythagorean theorem, we'll do a squared plus b squared equals c squared. Your c squared is 13 in this case because the radius, or the hypotenuse of this right triangle is 13. So we're going to do a squared, and I'm calling ZWA. B squared is 5 squared equals 13 squared. I believe this ends up being a Pythagorean triple, which is great. A squared equals plus 25 equals 169. We're going to subtract 25 from both sides, and you will get a perfect square here. You're going to get 144, which means A, when we square root, is 12. Not the answer, though. It's close to the answer. We're saying that this is 12, which means VZ is also 12. So the entire yellow line segment ends up being 24. Oop, that's not. VW equals, for number 13. And then number 14, I really like number 14. Find arc YW. They give you no information about the arc. There isn't even another chord to say that they're congruent to each other. So we can't even use the first roll up here if two chords are congruent, because there's only one chord in the diagram. So you can't even use what we just learned. So we have to actually go back to something we've learned previously. Arc YW, there's a central angle in this diagram, right at angle X, because this angle, right at X, that's a central angle. I know this diagram's a little bit confusing. Actually, I'm gonna erase a bunch, just so you guys can see a little bit better. But right here is a central angle. If we can find the measure of this angle right in here, we'll have the measure of the arc because they're congruent to each other. How could we possibly find the measure to that angle? Who can see it? Who knows what we have to do? What is the way we can solve for that angle? And we know this is 12. You can solve for that central angle using SOHCAHTOA. So this ends up being a SOHCAHTOA problem. Because we have a right triangle. And because we have the right triangle, we can find that angle. And because you know every side to the triangle, you can use any single one. I'll use the 5 and 13 because that's what they gave me in the problem. So that would force me to use cosine. So it would be the cosine of the angle. I'll use theta for the angle. Adjacent over hypotenuse, which is 5 over 13. So you can do the cosine to the -1 of 5 over 13, and that's going to give you your angle. That angle is exactly the same as the arc because it's a central angle. So this one I cannot do in my head. I am going to need a calculator of some sort. So cosine. Oh, nope. 5 over 13 inverse cosine. I get 67.4 degrees. And that's rounded. All right. But it's 11:41. I know I went a minute over. So that's fine. The next thing in your packet is a homework. Optional just for practice or whatnot. I think the assignment I'm going to give this week, I'm going to give this quiz. It's not going to be a quiz. You can cross off quiz. You can put homework. Reason being is you've had the extra credit test, which went towards the test grade for extra credit. You had a weekly, which weeklies count as quiz grades. We haven't ever had a homework grade, so I'm thinking of counting this as, a homework grade. Again, it's going to be worth probably more than double. Do next Friday? You mean this Friday? I'm inclined to say this Friday. I think if you guys disagree, but are we okay with one assignment per week? Is this a fair? Is this fair with the amount I stream and whatnot? Because I know some students in other classes are getting overwhelmed, but is one assignment per week? Is this fair? If you think you're overloaded, I can make it due next week. I have no problem with that. But you guys have to let me know how you guys are feeling. If you guys are stressed, if you haven't received anything yet, you'll probably get it today. I'll post it in Google Classroom. But like always, you can ask me questions, and I think that'll be fine. You don't have any even handwriting at all. That's dedication right there. But I will post this in Google Classroom. This will be a homework assignment. It's everything we've just done so far. It's probably even quicker than a weekly assignment. I mean, this is literally just naming some radii, central angles, and area, circumference. It's everything we've done so far up to this point. It's only 2 pages, 16 questions, but I think it's pretty fair. So I will put that into Google Classroom. But let me know if you're running into any issues, if you're overwhelmed, even if you're overwhelmed in a different class, let me know. I will be mindful of that. I have no problem giving extensions to people. You have to just let me know. You have to communicate with me. That's the most important thing. If you're in contact with me, you guys know I'm pretty easygoing. I'm not going to say no, like, must be handed in on Friday, otherwise 0. No, I'm not going to do that. Just let me know. But I will put this in Google Classroom so you can see it, but it's likely going to be delivered today. I will ask this again tomorrow if you guys got it. But we are done for the day. So thanks for tuning in. We had a pretty big attendance, which is good. And I'll see you all tomorrow. And remember, there's no stream on Thursday. Okay? I'll be sure to get this on Google Classroom probably at the end of my physics class. So this will be up by probably 1 o'clock today. All right? Have a nice day, guys. I will always post the assignments digitally, always. That way you can see what I want you to have done. So by all means, you can do it digitally if you like. I actually thought it looked really nice when you did it.